All right, this is the reassessment for rigid body equilibrium. It's the same problem from class. We have the guy on a diving board with the two support beams here, and we're trying to find the force applied by each beam with a 4-meter diving board that weighs 35 kilograms with a person standing on the very edge that weighs 80 kilograms. So the sum of forces, we're going to do the y direction because that's what way it will rotate. And for the person is equal to 0 because he's at rest. And we're going to normal force minus his mass times gravity. So normal force is equal to m2g. Here's a free body diagram for the board and for the person. And so the sum of forces for the board and the y direction are normal force 1 plus normal force 2 from the two support beams minus the force of gravity pulling down on the board and on the person standing on the board. So we know that the first normal force of the first beam is equal to m1g plus m2g minus m2. And now to find the normal force of the second beam, we're going to have to use torque. And we know that the sum of torques is 0 because it's not moving. So n2 times the radius, which is 1.5 from the rotation point, minus m1g times 2, which is 2 meters from the rotation point because it's halfway through. I should be drawn halfway, but minus m2g times 4 because it's 4 meters from the rotation point. So if we want to solve for normal force 2, we get m1g times 2 plus m2g times 4 divided by 1.5, which equals 2,548 newtons in the upward direction because it's positive. So for the first normal force, we can use this equation, and we can use m1g plus m2g minus the second normal force, which we just found. We plug in those numbers, and we get negative 1,421 newtons in the downward direction.